The National Electrical Code, or NEC, requires electrical devices mounted in non-metallic boxes to be bonded to reduce the risk of electrical shock. However, there is an exception for plastic boxes with plastic covers. NEC Article 250.146 states electrical equipment shall be connected to the equipment grounding conductor where required in Article 250, Part 5. It continues that if a non-metallic box is used, the box shall be grounded in accordance with one of the methods specified in Article 250, Part 5, and the device shall be connected to the equipment grounding conductor. However, NEC exception number 1 to Article 250.146 states listed plastic enclosures or assemblies that are not a part of and are not connected to metal structural members, raceways, or other enclosures, and that enclose only switches or receptacles shall not be required to be connected to an equipment grounding conductor. A building inspector may believe that the exception does not apply because the light switches are connected to metal wiring devices, such as the electrical panel. Therefore, the inspector may require the switches to be bonded. An argument can be made that the exception does apply in the following cases. Firstly, the plastic switch boxes are not connected to metal structural members, raceways, or other enclosures. Secondly, the plastic switch plates are not metallic. Thirdly, the light switches are contained solely within the plastic switch boxes. And fourthly, the switches are not connected to ground through the metal wiring devices. There are a few additional considerations to think about. The light switches may have bonding screws installed, but they are not connected to anything. The electrical panel is grounded, but the wiring devices are not connected to the panel's grounding system. Bonding the switches may create a ground loop and introduce electrical noise into the system. With all of this in mind, it is recommended that the NEC is reviewed with the inspector and the argument is presented. Examples of similar installations where bonding was not required can be provided. If necessary, consult with a licensed electrical engineer to support the position. If the inspector insists on bonding, consider the consequences of doing so and document any concerns in writing. The importance of proper grounding and bonding in electrical systems cannot be overstated. Grounding provides a path for fault current to return to the source, allowing overcurrent protection devices, such as circuit breakers or fuses, to trip and de-energize the circuit. Bonding, on the other hand, connects non-current carrying metal parts of electrical equipment and enclosures to create a low impedance path for fault current. This helps to minimize voltage differences between these parts, reducing the risk of electric shock. In the case of plastic switch boxes and plates, the NEC provides an exception to the general rule of bonding electrical devices. This exception recognizes that plastic is a non-conductive material and does not pose the same shock hazard as metal. However, it is important to understand the specific conditions under which this exception applies. Firstly, the plastic enclosure or assembly must be listed. This means that it has been tested and certified by a recognized testing laboratory to meet certain safety standards. Secondly, the enclosure or assembly must not be part of or connected to metal structural members, raceways, or other enclosures. This is to prevent the plastic enclosure from becoming a path for fault current if it is in contact with metal. Thirdly, the enclosure or assembly must enclose only switches or receptacles. This is to limit the potential for shock hazard if the enclosure were to become energized. If all of these conditions are met, the plastic enclosure or assembly is not required to be connected to an equipment grounding conductor. However, it is still important to ensure that the electrical devices within the enclosure are properly grounded. This can be done by connecting the device's grounding terminal to the equipment grounding conductor in the circuit. In some cases, a building inspector may interpret the NEC differently and require bonding even when the exception seems to apply. It is important to understand the inspector's reasoning and present a well-reasoned argument based on the specific circumstances of the installation. If the inspector is not persuaded, it may be necessary to consult with a licensed electrical engineer to obtain a professional opinion. Even if bonding is not required by the NEC, there may be situations where it is still a good idea to do so. For example, bonding can help to reduce electrical noise and improve the performance of sensitive electronic equipment. It can also provide an extra measure of safety in areas where there is a high risk of electrical shock, such as wet locations. Ultimately, the decision of whether or not to bond electrical devices in plastic enclosures is a complex one that depends on a variety of factors. It is important to carefully consider all of the relevant information and make an informed decision based on the specific circumstances of the installation. Here are some additional points to consider when evaluating the need for bonding in plastic switch boxes. Firstly, consider the type of wiring method used. If the wiring is run in metal conduit, the conduit itself will provide a grounding path. In this case, bonding the switch boxes may not be necessary. Secondly, consider the age of the wiring. Older wiring systems may not have an equipment grounding conductor. In this case, bonding the switch boxes may be necessary to provide a grounding path. Thirdly, consider the presence of sensitive electronic equipment. If there is sensitive electronic equipment in the area, bonding the switch boxes may help to reduce electrical noise and improve the performance of the equipment. Fourthly, consider the local electrical codes. Some local electrical codes may have more stringent requirements for bonding than the NEC. Be sure to check the local codes before making a decision about whether or not to bond the switch boxes. If the inspector is requiring bonding due to the connection to metal wiring devices, it is important to clarify what constitutes a metal wiring device. Does this include the metal screws that hold the switch plate in place? Does it include the metal yoke of the switch itself, even if it is isolated from the box? A detailed discussion with the inspector referencing the specific language of the NEC is crucial. When arguing the exception, emphasize the intent of the code, which is to prevent shock hazards. With plastic boxes and plates, the risk of shock from touching the switch is minimal. Additionally, consider providing documentation from the manufacturer of the plastic boxes and switches. Some manufacturers may provide specific instructions or recommendations regarding bonding in their products. This documentation can be used to support the argument that bonding is not required. Another point to consider is the potential for ground loops. If the switches are bonded to the equipment grounding conductor, and the metal wiring devices are also grounded, it could create a ground loop. Ground loops can cause electrical noise and interference, which can affect the performance of electronic equipment. If the inspector insists on bonding, ensure that the bonding is done correctly. Use appropriately sized grounding conductors and make sure that all connections are tight and secure. It is also important to document the bonding installation, including the date, the location of the bonding connections, and the name of the person who performed the work. This documentation can be useful if there are any future questions or concerns about the bonding installation. Ultimately, the decision of whether or not to bond the switches is a judgment call that must be made based on the specific circumstances of the installation, a thorough understanding of the NEC, and a careful consideration of the potential risks and benefits. If there is any doubt, it is always best to err on the side of caution and bond the switches. Here is a further breakdown of Article 250.146 in exception number 1. Firstly, Article 250.146 generally requires that electrical equipment be connected to the equipment grounding conductor. This is a fundamental safety requirement to ensure that fault currents can safely return to the source and trip over current protection devices. Secondly, the article clarifies that if a non-metallic box is used, it must be grounded according to Part 5 of Article 250, and the device within the box must also be connected to the equipment grounding conductor. This reinforces the general requirement for grounding and bonding, even when using non-metallic enclosures. Thirdly, exception number 1 provides the specific exception to the general rule. It states that listed plastic enclosures or assemblies are not required to be connected to an equipment grounding conductor if they meet certain conditions. Firstly, they are not part of or connected to metal structural members, raceways, or other enclosures. This condition ensures that the plastic enclosure is truly isolated from any potential ground paths through metal components. Secondly, they enclose only switches or receptacles. This limits the scope of the exception to devices that are less likely to pose a significant shock hazard. The inspector's interpretation that the exception does not apply because the light switches are connected to metal wiring devices raises a key question: what exactly constitutes a metal wiring device in this context? Does it refer to the metal screws used to mount the switch to the box? Does it refer to the metal yoke of the switch itself? Or does it refer to the metal conductors within the wiring system? If the inspector is interpreting metal wiring device to include the metal screws or the metal yoke of the switch, this interpretation may be overly restrictive. The intent of the exception is to address situations where the entire enclosure and its contents are effectively isolated from ground due to the use of plastic materials. The small amount of exposed metal on the switch itself may not significantly increase the risk of shock. However, if the inspector is interpreting metal wiring device to include the metal conductors within the wiring system, this interpretation may be more reasonable. If the metal conductors are directly connected to the switch, and the switch is not properly grounded, there could be a potential shock hazard. When presenting the argument that the exception applies, it is important to address the inspector's concerns about the metal wiring devices. Firstly, clarify what specific metal components the inspector is referring to. Secondly, explain why these components do not create a significant shock hazard in the context of the plastic enclosure. Thirdly, provide documentation from the manufacturer of the switches or enclosures that supports the argument that bonding is not required. In addition to the arguments presented, it may be helpful to provide the inspector with examples of similar installations where bonding was not required. This can demonstrate that the exception is commonly applied in practice and that the installation is consistent with industry standards. If the inspector remains unconvinced, consider consulting with a licensed electrical engineer to obtain a professional opinion. An electrical engineer can provide a detailed analysis of the installation and explain why the exception applies. The engineer can also provide documentation to support the argument that bonding is not required. If the inspector ultimately insists on bonding, it is important to document the concerns in writing. This documentation should include the reasons why bonding is not required, the potential consequences of bonding, and the fact that the bonding was performed against professional advice. This documentation can protect from liability if any problems arise as a result of the bonding. In addition to the concerns about ground loops and electrical noise, bonding the switches may also create a potential fire hazard. If a fault occurs in the wiring system, the fault current could flow through the bonding conductors and overheat them. This could potentially ignite nearby combustible materials. Before bonding the switches, it is important to carefully inspect the wiring system for any potential faults. Any fault should be corrected before proceeding with the bonding. The electrical panel is typically grounded to provide a path for fault current to return to the source. However, the wiring devices within the panel are not always connected to the panel's grounding system. This can create a potential shock hazard if a fault occurs in the wiring system. To mitigate this hazard, it is important to ensure that all wiring devices within the panel are properly grounded. This can be done by connecting the device's grounding terminal to the panel's grounding bus. Finally, remember that electrical codes and regulations are constantly evolving. It is important to stay up to date on the latest changes to the NEC and any local electrical codes. This can help to ensure that the electrical installations are safe and compliant.